So this question, carrying on the May 2017 paper, is an impulse question. So it says, at the side this safety nets and another skier falls normally into the safety net. Now you're given this equation, F is equal to the change in momentum divided by the change in time, but impulse is actually force times the change in time is equal to the change in momentum. Now what we've got here is, if the skier is travelling initially at this, you then want to stop the skier. So that's what you're hoping to do. You're trying to slow the skier down, you're trying to take the velocity to 0. So actually our F delta t should be equal to the change in momentum, which is mv minus mu. So in our case, what we've got here is 76 v minus u. Well, luckily for us, our v is going to be 0 minus our actual 9.6 of what he's coming in with. This then gives us an impulse of 76 multiplied by 9.6, which is 730 newtons. Now it's no, see, I've made the class mistake there. It's 730 newtons seconds. Now this is not quite right. You will get given the mark for newtons per second. However, you could also break it down to be kilogram meters per second. But newton seconds is fine. So you get the mark for 730 and the mark for newton seconds. Next question, carrying on with the impulse theme. Explain with reference to the change in momentum why a flexible safety net is less likely to harm the skier. Well, the key there is reference to change in momentum. F delta t is equal to your change in momentum, your mv minus mu. So what you want to do to have less damage to the skier, and that's the force, you want to make that smaller, because you can't not change momentum. To make that smaller, you have to make the change in time bigger. So what we want is we want a longer stopping time, which will reduce impulse force, therefore reducing the impact on the ski.